Hi everyone, welcome to Smart Math Online Tutor. Through this video, I'm going to give you a revision on progressions. Let's get started by looking at what are progressions. Simply, progressions are number patterns. In your syllabus, you have to study about two types of number patterns. The first type is arithmetic progression. Here is an example: 12, 14, 16 and 18, so on. If you see carefully, from 12 to 14 and from 14 to 16, 2 is increased when proceeding the terms. So, if you see carefully, 14 minus 12 or 18 minus 16 is equal to 2. The common difference between each term is equal to 2. So, first term we usually represent by A, and the common difference we usually represent by the letter D, and here are the equations used to find out the term of a number pattern or the arithmetic progression and the sum of the first few terms of a arithmetic progression. So these equations will be important for you when doing sums regarding progressions. The next type of progressions is the geometric progressions. If you see here, 12, 24 and 48 are in a geometric progression. Why do I say so? If you see carefully, 12 is multiplied by 2 to obtain 24 and 24 is multiplied by 2 to obtain 48. So, if you divide a term by the previous term, you get a common value. This value is called the common ratio of the geometric progression. If you take, just like before, we use A to represent the first term and R to represent the common ratio. These are the equations you will have to use in geometric progressions to find the term and the sum of geometric progressions. So let's move on to some questions. Question 1. On January 1st, Anne deposited 25 rupees in her till with the idea that every month she will deposit 10 rupees more than the amount of she did in the previous month. So here you have to clearly understand what type of a progression is this. In the first month she is depositing 25 rupees and when moving on the next month she is depositing 10 rupees more than the previous amount. So here you should understand that this is an arithmetic progression. What is the first question? Write the amount of money Anne deposited in the first 3 months. In the first month, if it is 25, second month will be 35 and third month will be 45 rupees. So this lies in an arithmetic progression. So we can write it like this. The second part of the question is, in which month does Anne deposit 195 rupees? So we have to find out the month in which she has deposited 195 rupees. For this, we use the equation of the term of an arithmetic progression. We know the term is 195. We know the first term is 25 and the common difference is 10. So we are going to substitute values like this and find out the value of n. So if you do the substitution, you will see n is equal to 18. So you can say Anne deposits 195 rupees in the 18th month. Moving on to the next part of the question. The third part is Anne's target is to collect 3000 rupees in 2 years. Explain giving reasons whether she can achieve her target. So at the end of 2 years, she must have 3000 rupees in her till. So let us see whether this is possible. Now in this case, we have to find out the sum of the amount of money in the till at the end of 2 years. So here in this case, we have to use the equation sum of the terms like this. So at the end of 2 years means 24 months. So I substitute 24 instead of n, and then remaining values are just as substituted like for A and D. And then once when you simplify, you get during 2 years, so at the end of 2 years, she has deposited 3,360 rupees, and that says it is more than 3,000 rupees, so her target is achieved. The second question, in a firework display, a sparkler which is lit shoots sparkles as follows. The first minute 512, second minute and third minute and so on. The first part is we have to show that the sparkler emits sparkles according to a geometric progression. So to show that this is a geometric progression, what we have to do is we have to show that there is a common ratio. So what we do is we divide a term by the previous term. So 256 by 512 is equal to half. And then if you do 128 divided by 256, that is also equal to half. So we can say there is a common ratio which is equal to half. So this is in a geometric progression. Then the next part of the question is how many sparkles are shot during the 7th minute. So we have to find T7, the 7th term of this progression. So T7 512, R is equal to half. N minus 1 is 7 minus 1, that is 6. So once substituted, you get the answer as 8. So 8 sparkles are released during the 7th minute. The third part of the question is if the sparkler dies out after emitting 2 sparkles, show that it was lit for 9 minutes. So you have to show it is lit for 9 minutes. For that, what you have to do is you have to show 2 sparkles are released in the 9th minute. For that, what you have to do is you take the Tn, instead of Tn you put 2 and the remaining values. So here you have to find n. You have to show n is equal to 9. That tells the sparkler will die at 9th minute. So here, once when you substitute, you get the answers like this. Here 256 is equal to 2 to the power n minus 1. We can equate the denominators and then you get, 256 is 2 to the power 8 and therefore you can equate the powers here. 8 is equal to n minus 1. So simply n is equal to 9. Therefore we can say the sparkler was alight for 9 minutes. Moving on to the third question of this video. In a circular compound, bricks are fixed in a way that the first tire has 7, second has 11 and the next tire has 15. If fixing of a single brick costs 10 rupees, show that the cost for fixing bricks in 15 tires exceeds 5,000 rupees. Now here you have to clearly understand 7, 11 and 15 lies in a arithmetic progression, and to find out the number of bricks in the first 15 tires, we have to find the sum of the first 15 terms of this progression. So if A is equal to 7 and D is equal to 4 and the N in this case is 15, we can substitute these terms in the equation related to finding the sum and find out how many bricks are there in the first 15 tires. So it gives us 525 as the answer. Now, if one brick is costing 10 rupees, 525 bricks will cost 5,250 rupees. So this shows it is more than 5,000 rupees. So we can say the cost exceeds 5,000 rupees. That marks the end of that question. Moving on to the fourth question. A cyclist practices by cycling along a track, the distance of one round of which is 400 meters. Now he cycles 1 round on the first day, 2 rounds on the second day and so on, increasing the number of rounds by 1 every successive day. So here the first part is to show that the total distance travelled by the cyclist during n days is Sn equals to 200 n times n plus 1. So first of all, we have to recognize what type of an progression is this. You see clearly the terms of the progression. It is 400, 800 and 1200 and so on, because each day he is increasing 1 round. 1 round is equal to 400 meters. So here you have to identify A is equal to 400 and D is also equal to 400. And then we are going to substitute these values in the equation of Sn in an arithmetic progression. So once when you substitute and simplify, you can easily show the above mentioned expression. Here, once substituted and simplified, you can take 400 n out, and then if you cancel 400 by 2, it will give you the answer as 200 n times n plus 1. Moving on to the fourth question's second part, the trainer of this competitor says that he should cycle at least 84,000 meters during practice before going to the competition. Find the minimum number of days he should practice to meet this requirement. So here once again we have already proved Sn is equal to 200 n times n plus 1. What we do is we substitute 84,000 instead of Sn and find out the value of n. Now once when you simplify it, you get the equation like this. Now you can cancel all the terms by 2 and you will get the equation like this. Now this is a quadratic equation. So you know how to simplify quadratic equations. You have to factorize and then it gives you n is equal to 20 or minus 21. We know number of days cannot be negative. So he should practice for 20 days. The next part of the question number 5. A metal sphere is dropped vertically downward from a building for a scientific study. It travelled 5 meters in the first second, 15 meters in the next second and 25 meters in the third second. So the first part of the question is, what is the distance travelled by the metal sphere during the 10th second? Now first of all you have to identify the progression 5, 15 and 25. It is increasing by 10. So this is an arithmetic progression. So A is equal to 5 and difference is equal to 10. To find out the 10th term, we substitute the values in Tn. So once substituted, A is equal to 5, N is equal to 10 and D is also equal to 10. You get the answer as 95. So in the 10th second, the sphere travels 95 meters. So with this answer, we are going to the second part. What is the total distance travelled by the metal sphere by the end of the 10th second? So total distance in this case, we have to use the equation Sn. So Sn is equal to n by 2 into 2a plus n minus 1 times d. Once substituted the values, you get the answer to be 500. So we can say the sphere travels 500 meters during the 10 seconds. The third part of this question tells us the initial height at which the sphere was released was 1120 meters and the team of researchers expected the metal sphere to reach the ground within t seconds, and if t is greater than or equal to 4 times root of 14, show that the expectation is realized. Now here you have to clearly understand in this case t is equal to n in the general term. So here because in the at the beginning of the question we said the first, second and third seconds. So here t is the position of the term. What we have to do is we have to substitute 1120 meters instead of Sn and find out whether n is equal to this given value. So once when you substitute and subject n, you get 2240 is equal to 10n squared, and then 224 is equal to n squared. You know 224 is equal to 16 into 14. Therefore, we can take n is equal to 4 times root of 14. So, by this we can tell that the expectation of these researchers is fulfilled. Moving on to the sixth question. The first term of a given arithmetic progression is 3 and the 11th term is 43. So, we have to show the common difference is 4. Now, according to this, A is equal to 3. Tn is this equation we use. Instead of Tn, we put T11 and find out an expression in terms of 43, A and D. Now, A, we know it is 3. So, we can substitute 3 instead of A. Now, you are getting 10D is equal to 40. So, very easily you can take D is equal to 4. The next part of this question says, find the sum of the first 20 terms of the progression that is obtained by removing the terms in the even positions of given progression such as second term, fourth term and the sixth term. So, according to this progression, the first term is 3 and the common difference is 4. So, we can write down few terms of this progression, and then because they are telling us to remove the even positions, I am going to remove the second position and the fourth position like this. That is 7 and 15 must be removed. So, once 7 and 15 are removed like this, we get a new progression that is 3, 11 and 19 and so on. Now, in this progression, A is still 3, but the common difference is not 4, it is 8. So using these two details, we find the sum of the first 20 terms. Instead of A, we substitute 3. Instead of D, we substitute 8, and N is equal to 20. So once you do the substitution, you get the answer 1580. Moving on to the 7th question of the video, the common ratio of a geometric progression is 2 and the sum of its first 6 terms is 7. So I can write down this detail. We have to find out the first term of this progression. So R is equal to 2 and S6 is equal to 7. So what we are going to do is we are going to use the sum of the first few terms of the geometric progression and substitute Sn to be 7 and R to be 2, and then we are going to find out the value of A from this equation. So once when you subject A, you get A is equal to 7 over 63, that is 1 over 9. So that is the first term of this geometric progression. The next part is to find the 5th term. It is quite very easy. What you have to do is to substitute values in the formula of Tn of a geometric progression. So instead of Tn, we put T5. A is 1 over 9. R is 2. So 2 to the power 4 is equal to 16 over 9. Moving on to the 8th question. There are 12 seats in the first row of a certain theatre. The remaining rows are arranged so that each row contains 5 seats more than the preceding row. So 12 row in the first and each row after that has 5 extra more than the previous. So here to understand, this is an arithmetic progression where A is equal to 12 and D is equal to 5. To find out the number of seats in the 5th row, we have to find out T5. That is, once substituted, the value is 32. So there are 32 seats in the 5th row. Next part of the question tells us how many seats are there in total in the first 20 rows. So here we have to find out Sn, the sum of the first 20 terms. When you substitute the values, you get 1190. The next part of this question tells us this theatre has exactly 21 rows arranged in the above manner. The manager claims that if an audience of 1300 take their seats, then all the seats will be occupied. Is this true or false? And give your reason. So what you have to do is to find out how many seats are there in total in the first 21 rows. So you have to put the equation of Sn and substitute the values and find out how many seats are there in the first 21 rows. So once when you do the substitution like this, you get it to be 1302. This is more than 1300. So if 1300 audience take seats, 2 seats will be extra. Therefore, the manager is wrong. Let's move on to the next question. Question number 9. It is observed that a certain type of germ on a glass slide spreads and occupies at the end of each day an area which is twice the area it occupied at the end of the previous day. If at the end of the first day the germ occupied an area of 3 millimeters squared on the slide, find the area on which the germ had spread by the end of the 6th day. So here you have to understand it is increasing twice. Therefore, this is a geometric progression where A is equal to 3. The first term is equal to 3 and the common ratio is equal to 2. So, by applying the formula of Sn, we can find out the total area in which the germ is spreaded at the end of the 6th day. Here, n is equal to 6. So, S6 can be found by substituting the values like this. It gives you the answer as 189 square millimeters. So the germ will be spreaded in an area of 189 square millimeters at the end of the 6th day. Moving on to the last question of this video, the 10th question. In a question and answer program, for every correct response to a given question, a cash prize is awarded such that the amount awarded for a correct response to a given question is twice the amount awarded in the previous question. Once again, the term twice comes, so you have to clearly understand this is again related to a geometric progression where they tell if 100 rupees is awarded for the first question, that is the first term, so A is equal to 100 and The common ratio is equal to 2. What are we going to find out? The amount for the sixth question of this competition. So we have to find out T6. Remember, not S6, it is T6. The sixth term of the progression we are going to find out. So we have to use the formula Tn is equal to AR to the power n minus 1. Once when you substitute it, very simply you can get the answer as 3,200 rupees, and that is the amount awarded for the sixth question. Hope I made myself clear regarding how to apply the formulae of geometric progression and arithmetic progressions and how to work out questions related to these progressions. See you with another Smart Math clip. Until then, goodbye.